Hi, I'm Joel Nylund. I'm one of the partners here at Solution Street. And throughout most of my career, I've had a lot of different titles. But today I'll be kind of talking to you as an architect. So the focus of my topic is don't blame me, it's a network problem. So we're going to talk about players and roles, layers, protocols, common problems I've faced over my career, troubleshooting, and then we'll kind of have a review at the end. So the players. So developers, they write the code. They're typically, when it comes to networking, they're dealing with socket level resources. They're dealing with libraries that they don't know how they work. But they typically look at some layer of software they're using as, this should just work, right? Unfortunately, it's not that simple. But system administrators, so these are the guys that configure the hardware, the OS, the NIC cards, kind of everything at the operating system. Network engineers, these are the guys or girls that configure the network gear, the routers, the switches, the firewalls. They do the wiring, all the other awesome devices that Ken mentioned. They now kind of take ownership, although security engineer could take it. Security engineer is kind of the guy that creates a lot of issues. So we'll talk about that too, but their job is to operate at a bunch of different levels if they're good, but you'll find a lot aren't, and because they operate only at a single level. So we'll talk about that too as we go on. So hopefully most of you guys are architects, so that's kind of the idea of this topic. So the job of the architect, in my opinion, is to bridge all these layers. So any one of the layers can look at a particular problem that's happening and say, it's not my problem. But if everyone does that, it will never get fixed. So what I always felt my job as a software architect and a systems architect, because I kind of do both. What do you guys think the difference between a software architect and a system architect is? Anyone know?
Software and system. So
what's a software and what's a system?
Application.
Yeah. System is more like a infrastructure.
OS is like OS versus application. But the OS is the network too. Networks have OS.
Yeah. So the way I look at it is software architects are guys that know this much about the systems and this much about the software. System architects are guys that know this much about the systems and this much about the software. So it's kind of, they both know a lot about both, but one is sort of an expert in all the stuff underneath the covers, and one is, you could call this layer 7 up and down, or layer 7 and down. But the way I look at architects are problem solvers. They're the people that need to figure out problems and never say to the end user, hey, don't blame me, it's a network problem. So, yeah, everyone loves this diagram. I had to throw it up because you guys have already talked about layers. That's the best one. We're going to get into mainly in here today, a little bit up here, but I think sometimes people look at this and go, oh, wow, that's a lot. So
I think it's cool though because it gives you examples of each layer. I use that when I'm preparing for interviews. I memorize that, and I've added notes.
That's awesome. I love it. So I'm going to talk about, that's kind of theoretical. This is kind of actual. So in our typical life, people will throw out layers here and there, but at the end of the day, most of the problems we're going to deal with end up, routers, NIC cards, operating systems, apps, firewalls, switches. They end up being pointing to that's my problem or that's my problem. So these are kind of the practical layers. They're not really some of them map to the OSI layer nicely, and others kind of span multiple of them. But this is kind of when we're troubleshooting. Typically, we're troubleshooting at the device level. So this kind of keeps the layering on the side left, but we're going to talk about protocols a little bit, just so everyone kind of has that kind of background on protocols and what protocols mean. And you'd be surprised how many software developers and software architects don't know protocol stuff at all. Particularly the difference between IP and TCPIP and what TCP gives you. We're going to talk a little bit about HTTP, a little bit about ICMP, and a little bit about UDP as well. So let's get into the protocols. So TCP/IP, what it gives you is a session, right? So for those of you that are not familiar, the idea of TCP on top of IP is it's supposed to provide a reliable connection. So if you're a developer and you want to talk from one machine to another machine over a socket, TCP is going to give you that, TCP IP is going to give you that kind of guaranteed connection.
I got it. That's what it does.
Exactly. So if the establishment process, the process goes like this: the host A says SYN, B says SYN ACK, A says ACK, and then he receives the ACK, and now we have a connection. We can talk merrily. So if you've ever heard of SYN flooding, that's attack, big time back in the day. Host A would just say SYN, and fill up the OS's or the routers table, and everybody would.
Yes,
you
DOS
know,
packet is also called SYN.
yes.
So if there's that much sinning, the demons get really busy.
Very, very busy. We'll talk about some ways to deal with that. That's good. I like it. You get a shirt for that. And then finning, teardown, assembler. A sends a fin, he sends an ACK, he sends a fin and a fin ACK, so you get the idea. Different types of TCP/IP. Unicast, multicast, anycast. So you need to know, unicast is one-to-one. So it's me, socket A, talking to socket B. Multicast is a way to send to multiple people at the same time. So if anybody's used WebLogic clustering, that uses multicast for clustering, or used to use multicast. I don't know if it still does. And the idea was, tell everybody at once via one efficient protocol. Anycast is really different, but it kind of sounds like the other two, so I thought I'd put it out there. And anycasting is really just a way to advertise a IP address in more than one spot. So let's say I have a website, www.solutionstreet.com, and my IP address is, I don't know, 1.1.1.2. With Anycast, I can advertise that IP address here in Virginia, and let's say in China too. So I want to have two servers on the same IP address. I can actually serve that IP up in two different places, which is pretty cool. That's what Anycast is. Same exact IP. Yes.
Yeah, those are the fault tolerance.
Yep. You look confused. You don't believe me?
How does this, like, contradicts BGP and everything else? So.
It uses BGP to make all that work, but yes, it does. So I'll tell you a story. I worked at a company called VeriSign, and one of the things we did was serve DNS traffic. And the size of the original file from way back when allows you to have 13 DNS servers. That's it. 13 IP addresses, A through whatever, K or F. They're the roots, and they're the GTLDs. And then, so basically, the internet for many, many years just had 13 root servers and 13 COM servers and 13 net servers and 13 org servers. And they're spread out all around the world. So a really smart person said, hey, we can get around this 13 problem by anycasting. So we started anycasting the J root and the J GTLD 10, 15 years ago. And now there's hundreds of root servers and hundreds of GTLD servers, at least the ones that VeriSign serves. They basically put one in every shopping mall. It's like Akamai. They want to put a root server and a GTLD server in every single ISP that they can get to host it, because it gives them 100% uptime, gives them faster speed. Basically can't take them down because they're everywhere. Before, when you're 13, no matter how big you got, no matter how much pipe you dragged into every data center, really hard to defend against the bad guys that Ken was talking about. Okay, UDP. Nobody talks about UDP, but it's actually used in the DNS world a ton, so I thought I'd throw it in there because I'm a DNS guy. What's that?
53.
Yes. So UDP is different than TCP/IP. It has no guarantee. It's fire and forget. Hope you get an answer back. So when people use UDP, they're like, why didn't it work? Well, sometimes it just doesn't work. That's how it is. It's by design. So HTTP, we'll come to this more often, but everything's over HTTP now. Used to be 5-10 years ago, we had a million different protocols. Now pretty much everything is HTTP. So if you have Firebug, it's great. Fire up a web page, turn on Firebug, you can just watch all the traffic. Google Tools does the same thing for you Google people. All right, so we're going to talk about that's protocols, common problems. So I love this term. Is coined by the other Joel. We call him Joel in software. For those of you guys that read him, the term's called leaky abstraction, so I'll let you read that paragraph real quick.
He's the other Joe, just to be
Yeah.
clear.
Yes, he's the other Joel. Yeah.
Is that part
Is it cut off?
Yeah, it's a leak.
Is that a leaky abstraction? The projector is a leaky abstraction. Great, that is bad. I don't know why that is. It's the image. That's what you get for throwing in the image at the last minute. There. I warped the image, but made the abstraction. There
You can guess.
I got most of that. Oh, Kurt.
So the gist here is that we have all these wonderful layers, and they provide all these wonderful layers of reliability. And so, like I said, when the software developer talks to a socket and says, connect to this server, they think it's just going to happen. Sometimes it doesn't happen. And what the other Joel coined this term is kind of leaky abstractions. So some quick examples of leaky abstractions that I've experienced. I had a big project I was building, and I had, I think it's 40 servers. And we were doing some load testing, and we weren't always using all 40. We were using like 2, and then 4, and then 8, and then 12. When we got to this one set of servers, the load results were always horrible. And we couldn't figure it out, you know, and I think the server was .13. And we kept coming back saying, this 13 server just isn't good. And we were having an argument about it, and one of the SAs walked by our office when we were talking. He's like, hey, 13 has a red light on it. We're like, we've been sitting here for 3 days racking our brains, and, you know, the SA, there's a light on it. I guess the light means there's some problem. I don't know what the problem was, but they took it out. NIC cards can fail in lots of weird ways. We'll talk about that later. Bugs in a code, a library used for a protocol, router misconfigurations. These are all kind of examples of leaky abstraction. This was my first real big, real life leaky abstraction. So I worked for an online brokerage with Arthur and some other folks here a few years back, and we were doing WebLogic clustering, and we had it all working perfectly. And this was bleeding edge, early days, first servers that we did clustering. And multicast was being used to share sessions. So we would test, take down server 1, leave server 2 up, take down server 3, start server 1 back up, and make sure that the user just kept on going and no problems all the way through.
You the state of what session being or state?
Stateless.
Okay.
But still had a session there logged in, you know, didn't want to use the login. Worked perfectly in development, worked perfectly in QA. Got to production, worked good for about 10 minutes, stopped working altogether. Tried everything, debugging it, hours and hours, just losing our mind. What's going on? So we got a really good system architect, sat down with them, kind of, you know, and the big difference here was they were hooked up to these big IP machines. So we had load balancers in front in production. QA we didn't, dev we didn't. And so he basically went into the production and brought a little $50 switch, ripped these suckers out of there, plugged it in, you know, plugged it into a router, let us hook up to it, worked perfect. Okay, so we figured out it was big IPs, okay? Why was it big IPs? Well, he did some research and reading and played with configs for a day or two and figured out basically Unicast uses ICMP under the cover, so Internet Control Messaging Protocol. Ping, traceroute, that kind of stuff. A lot of guys on the edge like to shut down ICMP because that's attacks. A lot of attacks use ICMP to flood the network. Yeah, so Big IP had this awesome feature where like it let you use ICMP for like 5 minutes and then it would shut you down.
Oh.
So that was a big, fun, long story, but leaky abstraction. Yeah. So let's go on to the next problem, common problem, blocked ports. So this is another big one. If you've ever worked at a big company with lots of servers and lots of different roles, you almost always get into some new environment and something doesn't work. And so what I like to do is use a tool called Netcat. So I'm going to do a quick demo on this just to show you guys how to use it.
Yeah, that's very good.
Yeah, so if you haven't used Netcat before, what Netcat allows you to do, it does UDP and TCP, but we're going to just stick with TCP for now. And it lets you basically simulate network traffic, or not really simulate, but actually speak network traffic. So this is an Ubuntu Linux server here. So I'm going to run netcat as a listener on port 80. And so what that is doing is simulating a web server. So here's my server A, it's a web server. Now my client is my Mac over here, and I want to test connectivity between my Mac, who's server B, and to see if I can get to the web server on server A. Okay, so I'm going to do netcat, the IP address of the Ubuntu server, and port 80. Hit enter, and I'm going to say hello world, and you'll see that it's echoing on the server side. So I can keep playing all day long and see if it'll hold the connection. If I'm having problems connecting at all, if I'm having problems holding connection, this is a great tool where I can just test very quickly. I don't have to run, you know, Apache. I don't have to run some fat client. Very simple tool that comes with almost every Linux distro. You may need to run on 80. You need to be sudo as root. So let's shut the port down. Make sure we can see how it would break. So I'm just going to use IP tables to shut the, sorry, wrong one here. Shut the port down here. So this is just going to do, so IP tables is a built-in firewall with Linux. And it basically lets you do rules. So this rule says, hey, block anything on ETH0, which is my network card, anything that's TCP traffic, anything that's coming to port 80. And new established, it basically says reject anything that comes up. So now I'm going to run listen on 80, and I'm going to try to talk to it, and nope, can't get there. Okay, so that's kind of showing you what, if you had a firewall in the middle, it would look like. And netcat says, hey, there's some problem. Doesn't tell you where the problem is yet. It's interesting that it fails that quickly. Not all firewalls will do this. Some will let you hang. Some will, you know, fail quickly. Some will take a few seconds. So this is kind of the particular. So let me kill this rule. So if I delete this rule back and turn my listener back on, best. Now I'm back up. So everybody's happy. So that's netcat. You can do UDP. You can do any port. And it's pretty cool little tool, so play with it on your own time. That's common network problem number 1, block ports.
Sorry, side question.
Yep.
What VM, where are you running your Ubuntu distro?
I use Fusion.
Fusion?
Oh, it is a, it comes from OS boxes, this one I just downloaded, but yeah, it's just VMware Fusion.
Okay.
Yeah, it's just a CAN VM. Yeah.
Cool.
Yeah, feel free to jump in, any questions on No, anytime, yeah, anytime. So another one, common problem is poorly configured NIC card. So a lot of people don't think about this, but whenever you get a new machine and it's acting slowly, you start thinking about all this. Does it have enough CPU? Does it have enough memory? Is the software installed right? Did I do something wrong? But a very common problem is a poorly configured NIC card. And a couple things that can be often misconfigured are duplicity. So is it full duplex or half duplex? A lot of times the auto negotiation will do half duplex, and you're like, so this is kind of how you can tell here. And I think that's the full duplex here. So 2 tools you can use, MI tool and ETH tool. And again, most Linux distros come with both. You can run either one. They'll tell you all about your NIC card, tell you what the speed is, 100 base T. And full duplex is what you want for, or better for really high-end stuff. So again, one problem here that I didn't talk about on the slide, but I was thinking about later, VMs, everybody's running VMs, right? You don't get this info on a VM. So how do you figure out how fast your virtual network card is? I'll leave that as a question for you guys to figure out. I don't know is the short answer. I think, you know, some of the VMs have tools you can use. I guess you could run, you know, flow through it and get something to measure it, kind of like speed tests for Wi-Fi. Maybe you need to get a speed test for your NIC card, but you don't really have access to a real NIC, so it doesn't give you all that stuff. At least Zen and VMware don't. Another big issue, wiring issue. If you have intermittent failures, if you have slow network throughput, you could have just a bad wire. Happens all the time. Kinked wire. Yeah, let me know. Looking good. So we have one of these here. We don't do a lot of our own wiring, but we have one of these. They're great. Just hook the Ethernet on one side, hook it on the other side, and it'll give you 7 lights or whatever, or how many ever it is, 13 lights. You know, every pin is good. Everybody's happy. So simple.
Yeah.
No?
No, the RJ45s, they have to be wired in a certain way.
Yes.
I mean, I've been having this argument with, younger guys. It's like, oh, as long as the wire's good, they're like, no.
Right.
They work for us. No. It's just like, you can connect 1, 2 to whatever, but certain wires have to go in certain things because the actual Ethernet thing assumes certain kinds of RF interference by the signal that's going.
Oh, the way they twist them.
Yes.
Yes.
Oh, yeah, yeah.
It
Yes.
requires them to be there. So that's why you have like, complex, like 55,
Mm-hmm.
but you have to wire them that way.
Yes.
You can't be straight.
True.
Those will tell you.
So you're right. That won't tell you that. I was more thinking you have a good wire and it went bad. This will tell you, right? If you had a properly wired wire and it went bad, it got kinked, it got broken, it got whatever, then this will tell you.
What problem I had was basically he put in one of his wires and, all of a sudden the network traffic would just like, break and like, what's happening here? And you test the wires like it's okay, but, if you wires are wrong.
Perfect. All right. Well, excellent. That's a good backup of it being a common problem.
I'm sorry, just to piggyback on that.
Yeah.
Same thing obviously applies to the fiber connection as well.
Absolutely.
Same thing.
Absolutely.
Same thing.
Great point. Great point. Yep. Another common issue, and this gets into layers. I should be saying this as we go. So this is usually a system administrator, but it could be the network guy that is in charge of this. Different shops have different rules on that. So misconfigured routes. So a lot of times on Linux, most really high-end networks will have a back network and a front network, right? So typically kind of ETH1, ETH2 type setup. So your back office network, to get in via SSH, to get in to do any kind of management, you have to come in through that. To get into from an end user perspective, coming in through your front office network, right? And so a lot of times when they set it up, because they're just using back office and they're not worried about the front office, everything will work great for them to get to the box and hop to the database or wherever they need to go. But if you want to get out and make a call to an external service provider, they won't always configure the routes properly, right? So this is another one that's happened at least 50 times to me over my career. So you can use the route command on Unix. It'll tell you the default route. It'll tell you, where it's going. And you can use traceroute too. Did I mention that in here? So you can use traceroute if they don't have it turned off, but a lot of times they have it turned off, which adds insult to injury. So traceroute will run and tell you where you're headed. So if you trying to go to Yahoo and you run traceroute and it's like going, through this to this back office machine, you have a misconfigured route, or you need them to add a route to let you get out the front door. Okay, moving up the stack, memory leaks. So common symptom, app starts fine, goes slow over time, uses up too much connections, too much memory. Typically, this happens when developers aren't closing their resources, especially in error conditions. So they're closing them in the happy path, but something bad happens all of a sudden, and now you're just hitting exception after exception and leaking connections all over the place. Using up connections, uses up memory, uses up ports. Eventually, everything's clogged up and nothing will work. One of the questions we always ask everybody that interviews here, the developer, can Java have a memory leak? Yes, it can. People think it can't. It's a garbage question, but native resources can leak. So that's memory leak, too many connections. Same issue, could be caused by a memory leak, but it could be just caused by too much traffic. People tend to look at devices as these amazing things, but really all these devices are operating systems and software, right? They're not magical boxes that can just do anything you want. So I had an app where I had to support, you know, tens of thousands of connections, simultaneous users. And a lot of load balancers can't do that. At least they couldn't a few years back. Maybe they can now. But load balancer is really just a table that maps source IP, source port, destination IP, destination port. And the table has a finite amount of memory and a finite amount of slots in it. And if you use them all up, either new guys get rejected or old guys get tossed out, right? So one or the other is a big problem. Routers have the same problem with NAT tables. Linux has a limit on the OS, a number of OS connections it can have, right? So there's a configured port range that says these are how many ports we're going to hand out. And if you use all those up on Linux, game over, right? And so if there's a SYN flood and they're sending up tens of thousands of connections, OS is puking, it's done. So firewall licensing rule, hit that one a few times, right? So they bought, you know, 10,000 concurrent connections or whatever, and they forced you to force all your traffic through the firewall, which then pukes because it won't let any more connections through. So it's the opposite of keeping out the bad guys, it's keeping out the good guys, right? Application, a lot of people do multi-threading. So, and if you're using threads and connections, you can only handle the number of connections one per thread, right? Not necessarily a good way to do it anymore, but kind of a typical thing. So, any questions on that? Okay. Application level protocol issue. Okay, so this is connection is there, but the app's not working properly, right? So again, just like a lot of people look at those machines as magical devices, they look at libraries as magical software that always works, right? So sometimes software doesn't work, right? So ways to debug, use Firebug if you can for HTTP. Use Wireshark. I think Ken mentioned that. I've spent so much time on Wireshark in my life. I wish I didn't, but I did. Sometimes the open source third-party library is the same. So I'll give you an example of this. So I worked at a large internet infrastructure company, and we had a SLA agreement with all our customers that we had to return 98% of the traffic questions in 3 seconds or something like that. Actually, I think it was sub-second or something. So these were all B2B protocol level transactions using custom protocol, not HTTP, and using SSL to encrypt, right? Two-way SSL. And when the company started doing this, there weren't a whole lot of SSL libraries for Java. This is like way, way back, probably 1997 or something like that. So they bought a commercial package called SS Lava, and who now owned by Oracle. But back then they were a standalone company, and they provided bidirectional SSL. So public key, private key. Sorry, client side key, server side key, both direction, right? And so it worked great for many years. And we had these SLA logs where people manage. They measure how long a transaction takes. And we always measure like right outside our firewall, really fast, right? And so we had some European customers that kept saying we were missing our SLA. I mean, they're getting belligerent out and they're trying to figure out a way to make us look bad. They just didn't like it. So we started looking into it and found out they were right. And in the US, everything was great. In Europe, not so good. What it turned out to be, after hours of looking through TCP dumps, was this SS Lava library. It wasn't, so those of you familiar with sockets and buffers. In Java, everything's buffered. And it wasn't flushing at the end of every request. It wasn't our control, it was the third-party library wasn't flushing. So in US, very, very slow latency, very quick. By nature, other traffic would come through and it would get flushed through, no problem. Europe, longer latency, bigger things. We're getting everything but that last byte through. Like basically, the flush wasn't happening, so we thought it was done. We'd sent it back, but the packet actually never arrived to Europe for like 3 more seconds. So we decompiled their Java code and found the one line, added the flush. Perfect, right? Crazy. So HTTPS, slow page loads. This is another big one we deal with a lot, right? Pages loading slow. Problems could be too many loadable elements on a page, not using gzip deflate. Hopefully you're all using gzip deflate. Big images or other resources. Is connection keep alive allowed by server or network gear? A lot of times it's turned on maybe on Apache, but maybe the network gear is like connections on there too long. Goodbye. So I'll show you this, a few websites, just to kind of give you a quick look at it. So I like Firebug. So Google used to be awesome. I'm sure. So this used to be 2 network calls, one for the Google image and one for the entire rest of the page. Now it's, you can't see the bottom. 18 requests, 545K. Still pretty fast, still pretty good. But, you know, even Google's kind of gotten way crazy on, this is just one page, right? 18 requests. Okay, solutionstreet.com, let's see how we did. Not too bad, 18 requests, 853K, lots of images, lots of fancy marketing stuff, lots of pictures of the team. Still pretty tight, right? That's pretty good, right? No? Okay. This is one, Sarah Now. I don't know what they are. They're a law firm, Sarah Now. Just found them on the web. Exactly. Get a good designer. 66 requests, 1.5 megs. Now we're getting there, right? All right, one more. Drupal Jedi. Any Drupal Jedis? 77 requests. 22 requests, 2.2 megs for the Drupal Jedi. Oh, and counting. It's still going. Okay. Yeah. Yes, exactly. So a lot of these problems can be solved by the use of a framework. And Ken didn't mention it, so I do want to mention it. There's one thing that we were surprised. We were doing an eval of some software 2 weeks ago. Use a framework. I mean, frameworks are great. Ruby has Rails. Python has Django. PHP has 700 different frameworks. Java has Spring MVC or structs or whatever you want, but they help you with security vulnerabilities. They help you with best practices of shrinking and combining your artifacts, your assets. They help you with good general best practices of your servers, turning the connection keep alive on, turning on gzip deflate. So Microsoft.NET, that's another good one. So anyway, use the framework, right? That'll help with a lot of this stuff.
Yeah, this framework can, if you use it, it's a good validation.
Yeah.
Use CDN.
That too. So let's review. Start simple, add complexity slowly, making sure everything works along the way. Do this in development, do this in QA, do this in production. Make your QA environments as much like production as practical. Make your dev environments as much as like QA as possible. When you run into a problem, start removing items from the equation one by one. Use tools like Netcat, Firebug, Wireshark to help you debug. Yes. We talked about all the players: SA, NA, SE, developer, architect. Your job as a great architect is to work with all these folks to solve problems. There are many layers. You need to know enough about all the layers to troubleshoot and find players and find problems. You don't need to be an expert at everything. I'm not an expert at everything, but you learn just enough to kind of understand what's going on everywhere, and you can help solve really hard problems. That's it.
Usually what I do is I find
Force them into the same room, maybe give them pizza, beer. Yeah, there you go.
So one thing that I wanted to mention was there are browser extensions that allow you to use similar network traffic, like PHP connection.
Yes. Great idea. Arthur covered that in his last low bandwidth. Chrome will help do a lot of stuff with simulation of different kinds of scenarios. Any other questions? Comments? Is that helpful?
Very much. Yeah, very good comment.
Cool. All right, great.
So the virtualized version, you both at the top.
Yeah, I think we need. Huh? Oh, good idea.
Oh, yeah, I have a question. For the optimization thing, a lot of profilers, that will send you a website, how to solve the bandwidth